as far as trying to find the solution to the differential equation, so multiply both sides by dx, divide both sides by y, and then looks like the variables are now separated. Integrate both sides. This side would be the natural log of the absolute value of y. This side would be x squared, and we need a c. Okay, so there's I guess close to my general solution. But to get rid of this natural log, you've seen this quite a few times now, and this worksheet really hammers that home to make sure that you're aware of how to deal with this. You can't just divide both sides by a natural log, because this is not natural log times y. This is natural log of y. It's a function of y. So the only way for you to get this to just be y is to go up here and say, make that the exponent on e, and then to keep it balanced, you got to make the other side the exponent on e. Now, because of that one logarithm property, a number whose exponent is log at the same base of something, that just gives us the something. Now, since c could go positive or negative, that allows us to not have to worry about the absolute value sign, luckily. Makes that a little bit easier. And then over here, split these two up. So normally you multiply things with the same base, you add the exponent. This time we're going to go the opposite direction. These exponents are being added. Let me separate them with multiplication. Okay, and probably the only other change that would need to be done if the question was to find the general solution is e is a number, and if it has an unknown exponent, then all of this is just an unknown number. So we would probably just call that c. A number to an unknown exponent is still going to be an unknown number. So if this question was find general solution, that's what you should do, and hopefully you're not struggling too much with that. If so, you need to get some extra practice, because I know this E step is a little harder, but that is important. That will come up many, many more times for you. Okay, but then they gave me some information to get the particular solution. So it says when x is 0, y is 2. So when x is 0, y is 2. And that's going to allow me to solve for that unknown constant. Let's see, 0 squared would be 0. Anything to the 0 power is 1. So it looks like c should be 2. Plug that back in. And you now have the particular solution. The solution that goes through 0, 2. Now the twist on this question, which of course we always need more practice on, because AP questions like to do lots of different twists. Doesn't really want the general solution or the particular solution, but what about when y equals e? What is x equal? So if we plugged in e for y, trying to figure out what number x there makes that true. Now, I guess if you had a calculator and it was decimals, you could probably just go into the equation solver at this point and save yourself a little bit of time. But the way I move forward here is you need to understand, I'm about to throw logarithms back in this question, but the only reason I even know to do logarithms is because I've got a variable up in my exponent, and there's no other algebra trick that allows you to get a variable out of the exponent except for logarithms. So that's what made me consider taking the log of both sides. Again, that's perfectly fine to do because it keeps my equation balanced. Natural log of e is just 1. This is saying e to what power gives you e, or you could just memorize it. But then here's where my mistake came in. I looked at this and I don't remember what I did, but what I didn't consider doing, that the person who made the solution guide did, is they looked at this and they said, all right, this is natural log of 2 times e to the x squared. Because of this 2, I can't do certain logarithm properties. This 2's like, it's just a problem. I can't just ignore it. Or if I ignore it, it's not going to be equivalent. So if you take that and you expand your logarithms, it would look like that. So expanding versus condensing logarithms. Did we do that in pre-cal last year?
Probably at some point.
Okay. I mean, I know it would have at least been in AMI. I just didn't remember. But this is considered condensed because it's one logarithm. This is considered expanded because it's multiple. So if this is natural log, when you expand it, it's natural log. If this is a plus, when you expand, it's a minus. If it was divide, this would be a subtract. Okay, and that deals with the 2, gets it out of the way. Now this guy, this is an exponent on something you're taking the log of. So this is why I even bothered to take the log of both sides, because that's the only way I was ever going to get that out of the exponent. Natural log of e is 1 again, and you get subtract over the natural log of 2, and you can take the square root of both sides, and then that's where the solution got their answer. So one of the things I'm going to, when I talk about the Khan Academy stuff here at the end of class, I'm going to refer to this again, because again, I don't mind telling you guys these logarithm properties, but it doesn't help you out a whole lot if you just see them 3 times per class. So, did you have a question on this one, Ty?
Wouldn't it have been a lot easier if you just didn't like solve the it for y, like y the after the natural log of like y, you rose the x squared to like e to be x squared would make it a lot easier to just stuff the natural log of y equals x squared plus the natural log of 2.
I'd have to look at your work to see which way you went with that. Are you sure your answer's the same?
That's exactly the same.
Oh, okay. Then potentially, yeah. I'll look at what you did.